Okay, sorry. I'm ready now. Thank you.
All right.
Yeah.
So was there any topic in particular you wanted to go through? I had a few we could do.
No, I'm all right. That's fine.
So I thought we could do congruent triangles, like proving that two triangles are congruent.
Okay.
Yeah. Okay.
Yeah. Good. That's good.
Um, um, okay, let's try this one. What are the angles? Hang on. Yeah. What are the angles A, B, and C?
Let's draw that very quick. So, because they're two parallel lines, A and B are, I think, corresponding angles.
Mm-hmm.
Well, first we know that A is 134 degrees.
Mm-hmm.
B would be also 134 degrees.
Mm-hmm.
And C would be 180 minus 134, which would give us 20. That would give us 46 degrees for C.
That's it. Okay. So what is your understanding of the word congruent?
Two congruent triangles would share one side, so one of the sides would be the same. Is that right?
So congruent means they're identical.
Okay.
And so it might be rotated around or slid across, but it won't be an enlargement. It'll be identical. So for this one, what is the side X? What is the angle Y?
Okay. So I'll just draw these two triangles. So those. Right. $112. So X is 5 centimeters if they're congruent, and then the angle Y would be 112 degrees.
That's it. So two triangles can be congruent if all sides are equal.
Okay.
So that's side, side, side. So all three sides the same length. Another way they can be congruent is if two sides are the same length and the angle in between those two sides is the same.
Okay.
Third way is if they have the same angle, and side. And then the last way is if they have a right angle, a hypotenuse, and one other side that's equal to each other. So from these ones here, so you say if it's side, 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 or side, angle, side, or angle, angle, side, or right angle, hypotenuse, and side. So let's say this one here. Which one would this be?
That would be side, angle, side, I think.
Yeah, so they both have, 5 and 6 and 80 degrees between them. So those two are congruent for the reason side, angle, side. How about this one?
That would be right angle, hypotenuse, and then side. So.
Right angle, yeah. How about this one?
Angle, side, and angle, I think.
Yeah. How about this one?
Side, side, side.
And this last one?
That would be angle, side, angle, I think.
Yeah. And so that shows that they are congruent if they have three sides the same, or side, angle, side, or angle, angle, side, or RHS. That shows that the two triangles are congruent.
Could you go to the previous slide if that's okay? Not the one there, just one before, if that's all right. So I could just copy those writing down.
Yeah. Okay, I'm just going to grab a drink. Are you okay for those?
Nearly done, sorry.
All right, come on, you can take it.
Yep, I got that, thank you.
Okay. And there are ways to prove that two triangles are congruent. Okay, so you have this first triangle, ABC, and then you have to say which other triangles are congruent to it.
Okay, so ABC, that would be... Right side. ED and F are congruent because it's got the side rule, the SSS rule.
Yeah. Are any of the others?
3. No, I think that's it.
And what is this missing third angle in the original one?
That would just be, 89, 99, 91 degrees.
So that's 91 degrees. This one has 91 degrees.
Oh yeah, that's true. So it would be corresponding as well, yeah.
And what would be the reason for these being congruent?
So that follows the side angle side rule.
That's it. So it's 491, 2.9, 491, 2.9. So those are also congruent for the reason of side angle side. You just have to sometimes find that third angle to make sure.
Okay.
And then this one is just totally different.
Yeah. Could I draw those triangles quickly?
Yeah, sure, yeah.
Yeah, that's fine. Thank you.
Okay, find the size of the angles in each triangle. Yeah, so what are all the missing triangles? Missing angles?
So put that one there. Right. So if we know that those are parallel lines. But what do those lines after? Because there's an arrowhead indicating it's parallel, but there's a line after that. What does that mean?
So that just means that those two lines are the same length as each other.
Okay, that's okay. So that's 110 degrees. Work out the size of all the angles. So if that's 110 degrees, and we can see an alternate angle from ABCD. So that means angle ABC would be 50 degrees.
Yeah.
50 degrees. And the angles in a triangle add up to 180 degrees. So 180 minus, then in brackets 50 plus 110 would give us 170. That'll be 10 degrees for the next angle there. 60.
I believe it's 20 degrees.
Oh, 20. Yeah, 20. Yeah, sorry. Yeah, 20
Sorry.
degrees. Yeah. So then the next angle, there's an angle that is just opposite to the 110. So that would be CED. That's also 110 degrees.
Mm-hmm.
What's that rule again called? You know when you say that those two angles?
Vertically opposite angles are equal.
Okay. That's fine. So then those two are vertically opposite. CDE would be 20 degrees because of the alternate angle rule.
Yeah,
And then
alternate angles are equal.
yeah.
Okay, so that's part A. And then part B, how do we show that these two triangles are congruent?
So they follow the angle. So angle. That's not. Is angle. Wait, I'll just check. So A. No, that's not a one. So they follow the side angle side. No, side angle side rule. Is that right?
Okay, so we're aiming towards angle side. Okay, so what two corresponding angles are the same?
So 20 degrees on one, and then 50 degrees, and then the two equal sides shown by the.
Okay, so angle BAC equals angle CDE.
Yeah.
CDE. Go on. What other angle?
So then you can say that angle ABC equals angle the DCB. And you can say the sides CD and AB are equal.
Yeah, CD equals AB. And I'm just going to throw in the fact that the other one is equal as well, AAB. AB equals CED, so angle CED. I'll just throw that in. But basically, so at this point we now say angle side, therefore congruent. And so you just need to give a reason at the end as to why they are congruent.
Okay, cool.
Any questions there?
That's fine, I got that.
Okay. Okay, let's try these.
I'll just draw that shape quickly. Okay. Okay, so we know that angle KLJ would be 119 degrees, because angles in a triangle add up to 180 degrees. And we know that okay, and angle JLN is also equal to 119 degrees, I think.
And how do you know that?
Because they're corresponding triangles because of the angle side angle rule. Angle side.
Okay. I think your way is probably better. Is if at this point you say, oh no. Sorry, what is the reason why they're congruent?
Is it because
actually you? If it was side, you could say they're congruent. The problem is at this point we can't say they're congruent because we don't know any angles in the other one.
Well, we know that they meet at the same like line, so they share a same side. So does that mean anything? Side.
Yes,
Yeah.
that's yeah. Actually, I would say that.
Side,
So
side.
yeah, so you don't even need to find any angles. That's okay. So we'll just leave that. Okay, so let's show that they are congruent.
Okay. So then, so we know that. So for A part. Wait, do you want me to do? Oh, just part B then, yeah.
Let's skip to part D.
Okay, sure. So, so they share side JL, and we can say KJ or J or yeah KJ
So
corres
I would say yeah, JL is a shared side.
yeah, and then JK corresponds to JM.
So I'd say it's equal to it, JM, because you for them to be congruent, you have to show that they're three equal sides.
Okay, so yeah, so it equals that, and then I can say that KL equals LM.
Okay, and then
Therefore, therefore, side. So
uh,
therefore,
yes, therefore congruent. So side, therefore congruent. And side is just short for, three sides are equal to each other.
okay.
And I think once you have shown that they are congruent, it is now so much easier to just say what the angles are. Like clearly that's 190, and if it's congruent, which it is, we've just proven it is, that's 35, that's 26. And so that's a much, I think, an easier way to do it. Just show that they're congruent first, and then we don't have to do anything after that.
Okay.
Any questions there?
No, I got that. That's fine.
Okay. How about this one?
So then I have two lines. Okay, so D F G B F G, and then M is the midpoint. So DM equals, I think, is it EM?
Yep.
And then it says which thing G. So GM equals FM.
Mm-hmm.
So then angle DMF. Okay. Angle DMF equals angle GME.
That's fine. So that's just necessary for this. Okay, let's try this.
Okay. So, and then I'll just draw the place. Yeah. Okay, so then those two.
I think this is. I think you'll be fine with this, to be honest.
Okay, that's fine.
This is the midpoint, and so those two sides are the same length, and those two sides are the same length.
Okay.
I just want to stick with the congruent stuff. Okay, prove that these true triangles are congruent.
Okay, so we know that AD and so DA and CB are parallel, and well, we know first of all we can say that they share the side AG or AC actually.
Yeah.
AC is the side. So AC. AC is a shared side. AB equals DC.
And why is that?
Because they are parallel and because AB because they're parallel lines, and also because they kind of have well because the alternate angle theory. So we know that angle DCA equals BAC.
So that would be for angles. This is a parallelogram.
Okay, right. So then they'd be say yeah. So because it's a parallelogram, is that what you said?
So what would be the reason?
Because, well, you can see that the line AC kind of cuts the parallelogram in half. So then, is it to do with because you can?
Opposite sides in a parallelogram are equal.
Okay.
In a parallelogram are equal, and they also happen to be parallel, but that's not relevant for this.
Okay.
Because there's no you don't prove that two triangles are congruent because two sides are parallel. It's not really, they could have rotated it so it's not parallel, but they'd still be congruent.
Okay.
Okay, what will be next?
So then you can say that DA equals CB.
And why is that?
CB. Opposite sides in a parallelogram are equal.
Next.
Are equal. So the next step would be you'd say that therefore side, or you'd say side, and then therefore it's congruent.
Therefore, yep. And that's just a short way of saying all three sides are the same, therefore triangle ACD is congruent with triangle ABC.
Okay.
Any questions about that one?
That's fine, got that.
What did they say? Length AB equals length CD. Opposite sides in parallelogram are equal. Opposite sides in parallel equal. Length AC is common to both triangles. So triangle ABC is congruent to triangle ADC SSS. And yeah, you always have to say that reason why. Okay, let's try this one.
So that is square. So then, okay, so then X, Y, W, Z. Okay, so they're congruent. So WY is a common side. So then XY equals WZ because opposite sides on all sides in a square are equal.
Go on.
Square are equal. Then you can say that XW equals YZ because the same rule, all sides.
And so because of that, I'm just going to take a little shortcut. XY equals WZ equals XW equals YZ. And so there I've shown that, and I just need to write that reason once. You could write it twice with the thing.
Oh yeah, that's true. So then you can just say side, therefore it's congruent.
That's it. Congruent. So that was parallelogram, that was square. This is a rectangle. I think you'll be fine for that.
Yeah, I think that's fine. I got the idea.
This is a rhombus. Take a look at this one.
Okay, so I'll draw that shape. Right, so then you can just say so P, Q, R, S, and then R. So then 6.2. You can say that SQ is a shared side.
Okay, yeah.
PQ equals SR.
Okay.
Because opposite sides in a rhombus are equal. Actually, no, I could just say PQ equals SR, which equals PS, which equals QR, because opposite sides,
Not just opposite sides.
because all sides in a rhombus are equal.
Yeah. Yeah, well done. Very good.
Then you can just say that. Well, it's proven to be side, but do you want the angle thing as well, or do you?
No, because we could, but we don't need to extra prove it.
Yeah, okay, that's fine. So then side, therefore congruent.
That's it. Okay, so some people would have done the 6.2 and the other one and done side angle side.
Okay.
So this is yes. So I skipped one earlier that was like this. Now we'll do this one because it's proving that they're congruent.
Okay, so now prove they're congruent. I'll draw that quickly. So, then L K J. So you have to prove that it's congruent. So you can say that angle LXJ equals angle KXM. So therefore, it's 54 degrees.
What's the reason?
Because what's it? Alternate? No, not alternate. Vertically opposite angles are equal.
Yeah.
Okay, so then we know that, and then we can say that L X equals XM because you could say because X is the midpoint
That's
of.
enough, I think. Yeah, sorry, go on.
Okay, yeah, so then X is the midpoint. Yeah, I think that should be enough. So.
Yeah, of LM. That's fine. Sorry, I thought you were going to do a much longer thing than that. Okay, yeah.
Of LM. So then we can say that KX equals XJ because X is the midpoint of KJ. Because X is midpoint KJ. And then you can just say then side angle side. Therefore, the triangles are congruent.
That's it. Any questions there?
No, that's fine.
So this one is very similar to one we just did. Let's see. Yeah, it's exactly the same. And so this in the previous one, so I noticed that you said so this angle here is also 54. And
Yeah.
the reason why I omitted that is because we don't even need to say what the angles are. We don't even need to say that XM is 3 or JX is 7.1. We just have to say that they're the same. If it has a side and a corresponding angle and a side, like corresponding sides are equal, corresponding angle is equal, and then the corresponding side is equal, then they are congruent.
Okay.
And you can see in this one they gave no numbers whatsoever, and that would still be the case. You would just you would just do the same thing, side angle side. Okay, let's try this one.
So then that's C, B, D, and A there. So then those are all equal sides.
You know what? That was too easy.
Okay.
Prove that ABD is congruent to CBD. What sides are equal to each other here?
So AB. So what's ABD and then CBD? Okay, yeah, you can say they share the side BD, and also that sides sides AB and then BC are equal. Hello?
Yeah, and what other sides?
I don't know if you can hear me, but I think the call's frozen on my side, so I'll just end the call now and then you can call me back. That's all right. Thanks.
Okay. Hey, Stefan?
Yep, okay, sorry. I think the call froze from my side or something.
Yeah, right. I could hear everything you said.
Okay.
Yeah, so you said shared side, you said AB equals BC, and then what would be the last thing you'd say?
Then you just say that AD equals DC because D is the midpoint of AC.
Yeah, and it even tells you that they're the same.
Yeah, oh yeah.
Okay, so now let's try. This doesn't seem very challenging, but okay, we'll try it.
RS equals ST.
No, I think you might. Oh, okay, go on.
Okay, yeah, I can. It's quite easy, but do you want me to do it? Or?
No, it's fine. So I think it's just too easy. Yeah, you do that. Shared side, these two you're told are the same, and then these two are the same because it's the midpoint.
Yeah.
This one we did one like it already.
Yeah, we did that.
This is a rhombus, which we did. Oh, hang on. There's 4 triangles. Prove that DEG and CFJ, DEG and CFG are congruent.
You just mentioned the shared side and then like the sides being equal because of the parallelogram, or because all sides in a rhombus are equal.
So let's see. C, D, G, E, F. G is the midpoint. Let's see, it's just 2. Yeah. Okay, let's try this one.
Okay, so I'll draw that. Then you have X, B, 3, Y. Okay, so then prove that triangle XAZ, so XZ is congruent to XBY. Okay, so you can say that, well, okay, so you can say that the one of the sides, so side XB equals XA, because it's shown there, but you don't have to say that.
And so you can say just given.
Yeah. The side and then side again. So then you can say that BY equals AZ because it's an isosceles triangle, and then because AZ is a point on X. I don't know how you'd like say that in words.
So I think you might need to do some extra stuff before that. Is the third side, or how do we get the third thing?
Yeah, because they're two isosceles. Yeah, so then you can say that XZ equals XY because they're isosceles triangles.
So they were looking at the triangles XAZ X, A, Z. Okay, so the second side and then the other one is that, yeah. So then that would be, so XY equals XZ.
Isosceles triangle, and then you can say.
Yeah. Okay, so I don't know what I'd call it, base sides. In an isosceles triangle are equal. Okay. Go are equal. And then we have to say the third thing.
Yeah.
Any idea how you go with the third one?
I don't know how you could say it in words. I mean, I know they're equal sides, but
So I think what you would have to say is X Y, or maybe I'll just keep it simple. XA plus AY equals XY.
okay, XA plus A. Yeah, so then you can say that which equals XB plus BZ, is that right?
XB plus BZ equals
XZ.
XZ. And so we can sub what we know into the other one.
Yeah, so then we can say that XA plus AY equals XB plus BZ.
XB plus BZ.
I'm trying to think. So you know that.
So you know that. Sorry, go on.
Is it that so XA plus AY? Yeah, could you? I didn't.
So I think what you could say is, so you know how XB and XA are the same as each other?
Yeah.
So you, instead of writing XB, you could write XA.
Yeah. Okay. So then, yeah, XA plus AY equals XA plus BZ. Okay. So then you can say AY equals BZ minus.
Yeah.
Okay.
And so AY equals BZ.
Mm-hmm.
Go on.
For side. No, you say side, and therefore they are congruent triangles.
Yeah, that's it. Yeah, so that's basically it. So the total side, take away the total sides are the same. This little bit here, they're the same as each other, and so this bit here would have to be equal.
Yeah.
Any questions there?
No, that's fine.
And then these prove that that triangle is congruent. I think you'll be fine. I just want to see how they laid out their thing. Is common to both triangles, that angle and a reason, that side and that reason, right angle hypotenuse side, therefore triangles are congruent. Okay. ALM and MNC. Okay, so we haven't seen a type like this. Let's try this.
Okay.
And if you want, I can sketch some stuff onto the diagram, if you tell me.
No, that's fine. So then I'll draw the triangle quickly. So then A L M B N C. Okay, so then prove that triangle ALM and MNC are congruent. Okay, so then Right, so then they're shared by parallelogram. So you can say that so A L M N, so then AL plus LB equals AM plus MC.
Why is that?
Oh no, that's not true because right, no, okay, so you could say that side LB equals MN
Okay.
because opposite sides in a parallelogram are equal.
Yeah.
Equal. Oh, sorry. So then you can say that those two are equal sides. So AL equals MN because because well, we know that they're two. Well, we know that BA and NM are parallel sides. So then you can say that. What would you do next? I don't know how you could like.
So M is the midpoint.
Midpoint. Yeah. So then you can say that. All right. So AM equals MC because it's given there. So M is midpoint.
So I'd say the reason is M is the midpoint of AC.
Yeah. The midpoint of AC. Um. So we have one side proven.
So far we only have, because we're doing the top and the bottom right triangles, actually only two triangles, and so we currently only have one side the same.
Yeah. So then you can say that. So say N is the midpoint of BC. Yeah. So then you can say BN is NC because we say that N is midpoint of BC. So we have those sides. I don't know how we could prove that AL equals MN.
What do you know about the side LM?
That it's equal to. Oh, right, yeah. So LM is equal to BN.
Mm-hmm.
I think I've got this now. So LM equals BN. Because you can say opposite sides in a parallelogram are equal.
Mm-hmm.
Equal. If those two sides are equal, then LN is equal. So therefore, and we can, because we know that these are all equal, so we can say that so MN is a shared side of triangles. Actually, what could you do next from here? I'm not too sure.
So we said LM is equal to BN.
Yeah,
What else is equal to BN?
BN, NC.
Yeah. And so therefore,
LM equals NC.
yeah. So LM equals NC, and so that's a second side in our two triangles.
Okay.
So what are the two third sides, and let's try to make them equal.
So they're LA and NM. Those. We can say that it's an alternate angle, but I don't know how you could. Yes, it is an alternate angle there. So
what do you know about L?
L is the midpoint of AB.
Yep. Therefore,
Therefore, so then LB equals LA.
yeah.
And we know that LB equals equals MN, so therefore LA equals MN.
Yeah.
Okay.
The midpoint of AB and yeah, therefore AL equals MN.
Okay. Is that all you need? Oh yeah, then you have to say side, 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 and therefore it's congruent.
Yeah. Side, 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 therefore congruent. Any questions there?
No, that's fine.
Okay, so yeah, use the midpoints and with a parallelogram, you know, the opposite sides are equal.
Yeah.
So you can use those together. Midpoint, 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 opposite sides in the parallelogram, opposite sides in the parallelogram. Yeah, so they did side, side, side as well, not angles. And then this thing, okay.
ABE is congruent for A and B. Congruent to, which one is it? GDA.
And these are
AD.
two big squares. Okay.
So yeah, so they're squares. So we know that, we know that side. Yeah, so side EA equals side. Yeah, so EA is a shared side for the square. The square FA. FGEA and triangle EDA, so therefore it's the same side.
Let's see. So it's the triangle A. A, B, E. So it's that triangle there.
Yeah.
And then it was A, D, G. So the triangles don't share any sides. And so you were saying A, E.
Actually, I don't think that will really help. So.
Okay, yeah. So AE. Okay, what could you say about?
Well.
No, maybe it won't help.
No, I don't think it will help because yeah, they're two squares. The squares aren't the same size anyway. So you could say that there's a point between G, D. We could say that's. You can say that GD equals EB. Because actually no, they're not. I don't think they're congruent because it looks like because that's a right-angled triangle. It's frozen again. Sorry, I'll just end the call. Oh no, wait, can you hear me?
Yeah, I can hear you. Can you hear me?
Oh yeah, it's fine. Sorry.
Right.
So I don't think they would be congruent because that's a right-angled triangle there, and by Pythagoras, because it's like a squared plus b squared equals c squared.
Yeah. So the two squares aren't congruent.
No, they're not. But would the two triangles be? I don't see how they would be because.
Yeah. So what do you notice
Oh no,
about.
they would. No, it's fine. No, it's fine because I see that the. No, yeah, don't worry. Can you carry on? Sorry, I didn't.
So, do you notice anything about the sides AD and AB?
They would be the same, wouldn't they? Yeah, because it's on a square.
Yeah.
So yeah. AD equals AB, and you can say because they're on a square. Squares
Yeah.
all
All sides in the square are equal. Okay.
equal. So that's one side proven, and then you need those other two. So you could say that DGA. I can't. I'm not. How would you do the other?
So, could you use a similar thing for the other square?
Oh yeah. You could say that. So the other square, you have two sides there. You could say that EA equals AG.
Mm-hmm.
AG. Then you say all sides in a square are equal. Yeah. So then you have two sides proven. So what else?
So now we
Yeah.
just have to show the third one,
Yeah.
which is BE and
D.
DG.
Yeah.
Okay, so is there some way to know that right away, or do we need to do something first?
Um. So I can't think how you could do that. Yeah.
Um, let's see. How could we show that D to G equals E to B? Or is it possible that they have a shared angle or something like that?
It looks. It could be because I don't.
There's an obtuse angle in that angle. Not necessarily. Okay, so these third sides. Angle, side, right angle, hypotenuse. They're not both. No. I'm not sure how to get the third side here. So B say B to E is the same as D to G. Why is that? Is that side not a right angle? So that there, that would be E to G. So we're trying to show B to E, is it? Yeah, that's B to E is the hypotenuse there. And then D to G is not the hypotenuse in any triangle.
You could extend it down. So if you had like, you could make another right angle triangle with that, and then try and prove why they would be. congruent. Like if you just extended the line D, not really. I don't think like that. If you just so where it goes from G to D, if you make that a little bit longer, so from the point D, if you oh yeah, you could also do that. I see that as well. So
I don't know if that will work though. So this one is this little square plus this side. This is the... It might have something to do with Pythagoras, like this side is the square root of this squared and this squared. Some reason that I'm missing. I think it might have something to do with Pythagoras somehow. Maybe there's something to do with like ED squared plus DA squared equals
EA squared, and then
EA squared. And so that contains that. Does it have something to do with that?
I don't know.
EC squared plus CB squared equals EB squared. That BC is equal to DA. So you could sub that in. So EC squared. So DA and CB are the same. And we're trying to get EB. So I'll put DA squared there. So E to C, DA squared equals EB squared. I think it's something along those lines. So this squared plus this squared is equal to the one we want squared. And then in this other one, that goes there. I don't know. I'd have to look into it. I think there's something to do with Pythagoras, but anyway.
Okay.
Anyway.
I'll draw that. Maybe I could try doing it for homework or something. I don't know.
Okay, yeah. We just need to show somehow that these two are the same length, and then it's just side, side, side.
Okay.
I believe. Yeah, how is that for you, Stefan?
I think the first questions were quite easy to get, but maybe if you could email me some of those harder type questions for congruency to practice, I think that would be good.
Okay. Anything in particular you want to do next time?
Because I've got I think it's what's it called? Yeah, so I'm you know how I'm doing the further maths as well?
Yeah.
Could you maybe start doing some of those topics to teach me?
Oh, okay, so something on further maths, yeah. Yeah. Any questions for me in general?
I just wanted to say, so further maths, what I've heard is that it's quite overlapping with the current maths, like the GCSE maths that I'm doing. So I think it's pretty much the same, similar, but
maybe I'll choose like non-overlapping
okay.
topics with GCSE.
Yeah.
Yeah. Yeah. Okay. Any other questions?
No, that's fine. Thank you.
Okay. Well done, Stefan. You did great. I look forward to chatting again next week.
Speak to you next week. Thank you.
All right. Have a good week. Goodbye.
Bye.
по-другому ноги помыть.